Okay, so you're going to go to page 1 of your packet. So this is the first lesson that we want you guys to be to know before you go to geometry next year. What's going to happen with this packet is at the end of the week, it is going to be your last daily grade. So please make sure you're following along with us. Okay, so let's make sure we're focused. Okay. It is, but you also have to know certain things because you're going to be using square roots and cube roots in geometry because triangles, you have to know the side measures, and some of those are square root of 2, square root of 3, whatever. Okay, so here we go. Roots are the inverse. Roots are the inverse of exponents. So I'm recording this lesson right now, recording this lesson for the at-home learners and people who aren't here. So we're on page...
Appropriate.
Yeah, what he said.
Okay. We're on page 1 of the packet. Roots are the inverse of exponents. They undo what exponents do. They're the opposite. So here's an example. Square root of 25 equals 5. Okay, so 5 squared equals 25. So it's the opposite of exponents. So this check mark symbol is called a root or a radical. It's like the 80s. Radical. Yeah, we've talked about this a lot. Nope. It's not like y'all remember everything in this class. Okay, so to solve the square root of 25, you're trying to find blank times blank. It's one number times itself that will equal 25. We know it's 5 times 5 because both blanks have to be filled with the same number. Hence, a number times itself. All right, so here's something that's super important. Put a star by it. A square root yields a positive and a negative solution. So let's look at how that's possible. Square root of 64. What number times itself equals 64? 8. So 8 times 8 is 64. But also, remember, negative 8 times a negative 8 is a positive 64. Because those negatives cancel. So really, the answer to square root of 64 is plus or minus 8. Okay? Plus or minus 8. Now, 100. 100. What number times itself equals 100? 10. Plus or minus 10. What number times itself equals 81? 9. Plus or minus 80. Plus or minus 9. Okay, so now look here. We're going to solve the following using the order of operations. So that is PEMDAS, my friends. PEMDAS. So 2 times 8. 2 times 8. You do what's inside the parentheses first. So, I mean not in the parentheses. You multiply first because there's no parentheses, there's no exponents. This is not an exponent, it's a square root. It's the inverse of an exponent. But there is some multiplication. So we're going to do 2 times 8 first. In the radical, 2 times 8 is 16. Okay, well now, what is the square root of 16? Plus or minus 4. Good. So multiply what's underneath the radical first. And you get plus or minus 5.
10.
And then 4 times 25 is 100. This is going to be plus or minus 10. Okay? So look down here. It says square roots are not the only roots. Sometimes you might have third roots. We call these cubed roots. Cubed root. If you look down here at the bottom, number 10, it's a fourth root, 11 is a fifth root, and 12 is a fourth root. So this number that's in the square root is called an index. That's the math term. the little number that tells us what it is an index. Look at the little cloud. It's a little note. If an index is not written, if it's just blank, then we need to understand that it's a square root. The number would be 2. The index would be 2. This number inside of the radical is called a radicand. A radicand. So, to solve a cubed root of 64, you're trying to find a number times itself 3 times that will equal 64. What number times itself 3 times would equal 64? 4. Good. 4 times 4 times 4 is 64. Do you know what number times itself 3 times would equal 8? 2. What about 1,000? 10. 10 times 10 is 100, times 10 is 1,000. Good. What about 27? 3. Good. So, look at this question. Can you have a negative solution for a cubed root? No. Because you're multiplying the same number 3 times. So if you have a negative 2 times negative 2 times negative 2, that's going to give you a negative 8. And you can't, it's just going to, that wouldn't be, you can't have a cubed root of a negative 8. You can't put anything under a radical that's negative. We only could do that for a square root because it's even. You could do it for the 4th root or a 6th root. So anything that's an even numbered root, you can do positive or negative, but not odd number roots. Okay, so let's try some other roots down here. 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is 2.
10.
And it's positive or negative. Good. Because it's an even numbered root.
10.
This is 10. It can't be positive or negative because this is an odd numbered root.
3.
And then 3. Positive or negative 3. Okay? Perfect. We're going to go to lesson 2, which is on the next page. Today is the only day we're covering 2 lessons in one. All the rest of the days this week we'll be covering 1 lesson each day. Okay? Alright, so number 1. So what we're going to do here is the odd numbers together, and we're not going to worry about the even numbers just because of time today. Okay? Okay, so number 1, is that a perfect square? Is 32 a perfect square?
Yes.
It is? What times itself equals 32? Nothing. Okay? These are your perfect squares. This is a reference guide on the back of the first page. These are the perfect squares. 1, 4, 9, 16, 25, 36, and so on. Perfect cubes. These are things that you can multiply times themselves 3 times. And those are the perfect cubes. Perfect squares is what we'll be looking at the most today. 32 is not a perfect square. So you could, theoretically, on the calculator, you could take the square root by pressing second and x squared of 32, and you would get this, 5.6568, blah, blah, blah. Okay? But that is not going to work here because in geometry, your teacher is not going to want you just to plug in a number into the calculator and get a big long decimal. They're going to want you to do what we call simplifying. So you take that 32 and you have to break it down. And you have to try to break it down to factors, and one of your factors needs to be a perfect square. So, for instance, factors of 32, 2 times 16. 16 is a perfect square, right? What times itself equals 16? 4. So 2 times 16 is 32, and 16 is made up of 4 times 4. So this is how it works. So watch this. Because we had our perfect square, we pull that out, And that perfect square number, that 4, just one of them, it represents the pair. It's going to go outside of the radical. You pull it out, and you leave the other number that you can't simplify anymore, like 2, inside. And this is your answer. So let me show you that the square root of 32 and 4 times the square root of 2 is the same. We already did square root of 32 on the calculator. Now watch, 4 times the square root of 2. Same answer. Okay? Alright, so let's look at number 3. 108 is our number. It's not a perfect square, so let's look at the factors of 108. I just start with 2 and go from there. 108 divided by 2, well 54 is not a perfect square, so we can't stop there. 108 divided by 3, that's a perfect square, 36. So I'm going to use 3 times 36.
Teachers, please pardon this interruption. Teachers, please pardon this interruption. This announcement is for teachers. Teachers, if you are needing to leave, if you're in a low-lying area and feel the need to leave, please let us know so that we can try to get coverage. We may need to combine some classes for those that are needing to leave. So please let us know if you are needing to do that. At this time, we are still intending to have school tomorrow. That call will not be made until in the morning if we will have school or not. But teachers, we are asking that everyone put something in Google Drive in case there is,
That means you don't have to make it up.
School tomorrow. At this time, we do intend to have
Well,
school.
that means we don't have to make the time up. If we put something for you to do in Google Drive,
Were you still counting here?
Yes, smaller words.
what I will give you to do is the rest of these problems. Okay?
Oh. You know,
Did you see that? Did I just do this with my hands, my air quotes?
Hey, you're on camera.
I'm not on air. I am on camera. It doesn't matter.
You can edit it.
I am giving you something to do. Okay? All right. So 6 times 6 is, so 36 is a perfect square. All right? So we're going to pull that 6 outside of the radical, and we're going to leave the 3, which is the other factor of 108, inside the radical. And that is our answer. All right, what do you see about number 5 that's different?
It has a V.
It has a V. We have a variable. I'm going to show you what to do with that in just a second, but first, let's treat the number. Just look at the number 80 first. Don't worry about the variable yet.
40.
All right, so 80 divided by 2 is 40. 40 is not a perfect square, so 80 divided by 3 is not a whole number, so it's not 3. 80 divided by 4 is 20. That's not a perfect square.
8.
80 divided by 5
8.
is 5. 5 and 16, because 16 is a perfect square. Okay? 5 times 16 is 80.
Did you do like 8 and 2?
No, because neither 8 nor 10 are perfect squares.
9. 10 can be squared.
Yeah.
I can't watch it.
Okay. So what are we going to pull on the outside of the radical? 4. Radical. 5 on the inside. That's our other factor. And this is where we put the V on the inside this time, because this little v, the exponent is to the 1. Okay? You can't take the square root of anything to the 1 because it's simplified to its very base. You can't simplify it anymore. So that means that you're just going to have to attach it and put it inside the square root. Let's look at the next one. It's going to be a little different. 72. Factors of 72 are 72 divided by 2 is what? 36. Is 36 a square? Yes. So we're going to use 2 and 36. That's 6 times 6. So we're going to pull the 6 out. The 2 goes on the inside. That's our other digit. Okay, now look at this a. This is a to the fourth. You can take a square root of a to the fourth. What times itself is going to equal a to the fourth? Yes, a squared. So because we could take the square root of a to the fourth, we pull that a squared out, and it goes with the 6. Only because you could take the square root of it. So let's, we're going to go to page 2, and I want you to look at number 13. Let's look at 11 first. 11. We're going to skip number 9 just for time's sake. But 11, right here. 252 is not a perfect square. And neither is 252 divided by 6. It's 126. Or 3, that's 84. 252 divided by 4, 63. Nope. It's not divisible by 5. Let's see what 6 is. Nope. 7 times 36, because 36 is a perfect square. Okay? So we're going to pull that 6 out. We're going to put the 7 on the inside. All right, so look at your variables. X to the third, y to the fourth.
X to the third on the inside, and y squared on the outside.
Yes, x to the third, you can't take the square root of x to the third. It is simplified as much as it will get right now. In this class, this is where we're going to stop there. Now, y to the fourth, you can. It can be pulled out and it will be y squared. So I want you to keep this as your answer. Look at number 15. 448. See if you can figure out the factors of 448, the first factor that will produce a perfect square. Nope. 7. 7 times 64. 64 is a perfect square. 8 times 8. So we're going to pull the 8 out. That's what you meant. Yeah. Okay, and we have a 7 on the inside. That's 7. Okay, so what's going to go on the inside? X. What goes on the outside with the 8? Y squared.
Put an X on the outside.
Z squared.
No, because,
It's a 1.
1x times 1x is 1x.
yeah, exactly. You can't square.
No. No. 1x times 1x is x squared.
Oh.
You know what I mean? You have to add your exponents. Or x to the 1 times x to the 1. So this is what you end up doing here. Okay, and we're going to stop there.
Y squared.
So if we don't have school tomorrow, your work will just be to do the even numbers. And done.